Alright, what we've got here is a function x squared times sine squared of 3x. And they're asking us to differentiate it and then determine the equation of a tangent and a line perpendicular to the tangent at x equals 1. So we've got to differentiate this thing. Now, because we've got one function multiplying another function, we've got to use the product rule, which looks like this. V times du plus u times dv. So we're going to differentiate this, and then substitute them. So we're going to say that u equals x squared and that v equals sine of 3x. To make it easier, I'm going to say all squared. Get the same thing. Alright, so now du equals 2x. Now, we want to find out dv. The problem is we've got to use, because we've got a function being squared, we've then got to use the chain rule to do that. So I'm going to rewrite this in terms of y. So we've got y, as a function of y rather. Y equals sine 3x all squared. And I'm going to say u equals sine of 3x. There are probably quicker ways to do it. I know this works, and it's also good practice for you using a chain rule. So let's go there. So now I'm going to say that from there, du dx equals 3 cos 3x, and y, so y equals u squared. So then dy du equals 2u. So now dy dx, a derivative of this, we multiply this by that. Oh, sorry, this multiply the two derivatives. So we end up with 6 sine 3x cos 3x. So that's our derivative there. So now what we do is then we add, so now that we've got that bit of information, we've got dv. So we tell us that dv equals 6 sine of 3x times cos of 3x. Okay, now that we've got that, we've got u, we've got v, we've got du, we've got dv. We just substitute into this thing here. So I'm going to move some stuff around a little bit. Sorry for coffee. So that's all the information that we need. Now, like I said, we're going to substitute. So we're going to put v. So we're going to put sine of 3x, sine squared 3x, times du, which is 2x. And we're going to say plus u, which is x squared, times by dv, which is 6 sine 3x cos 3x. Okay, so that's what we've ended up with. So we can just write, we generally write out x's coefficients of trig functions. So we've got 2x sine squared of 3x plus x squared, 6x squared, 6x squared, sine 3x cos 3x. Now, so we've got that. That's our derivative. Alright, so this is our derivative to this. Now what we want to do is we want to find the equation of the tangent at x equals 1 and then the equation of the line perpendicular to the tangent at x equals 1. So to do those at x equals 1, what we've got to do, we've got to find the derivative at x equals 1. So we substitute 1 into this. So I'm going to write m at x equals 1. So we've got 2 times 1 times sine of 3 plus 6 times 1 squared plus, times sine of 3 cos cos of 3. So because we don't have we can't find an exact value, we don't have a nice number to deal with in terms of what we're finding sine and cos of. Substitute that into your CAS, and we end up with that value being negative 0.7984. So when x equals 1, the gradient of this function, of our original function, is 0.79, negative 0.7984. So we want to find the line. So now if we want to find the equation to the tangent, what we're going to do is we're going to substitute. So that's a value for m. We have to use y minus y1 equals m x minus x1. So now we've got a value of m. We can substitute that in there. We've got a value of x, which is 1. We just need to find a value of y. So to find our value of y, we substitute 1 into the original. So y1 equals 1 squared sine of 3 all squared. And we end up with 0.0199. Now, from there, what we're going to do is we're going to substitute into our equation for the new graph. So we've got y minus 0.0199 equals negative 0.7984, open brackets x minus 1, and we simplify and solve. We'll find that y equals negative 0.7984 x plus 0.8183. So there we have gradient. So there we have our equation to our tangent. Next thing we're going to do is find the equation to the line perpendicular to the tangent. So I'm going to have to clean this up a little bit. So I'm just going to pause this, and when we come back, this will be all cleared up. We'll find a couple of bits of information as well. Okay, for this last part of this absolute saga of a problem, I had no idea it was going to be this long when I came up with it. What we've got, we're going to find the equation of the line perpendicular to the tangent at x equals 1. So we've got so if x equals 1, y equals that, 0.0199. And if we've got our value for m, well, if we're finding perpendicular, we've got to take the negative reciprocal of this. So I'm going to say that m of the perpendicular equals negative 1 over negative 0.7984. So from there, that ends up being, gradient perpendicular is 1.125. Sorry, no. 1.2525. And now once again we use y minus y1 equals m x minus x1. So we substitute our values. So y minus 0.0199 equals m, which for the perpendicular is 1.2525. Substitute x minus 1. We go through the rigmarole of substitution, multiplication, expansion, and we end up with y equals 1.2525 x minus 1.2326. So, just as a bit of a recap, this we're to use a product rule for, which we did successfully. Once determine the equation of a tangent, which means we've got to find the gradient at this point, the x value and the y value at that point, and then substitute into this equation. Want to find the perpendicular? We still need to find the gradient, but we take the negative reciprocal of it. And then once again, we use y minus y1 equals mx minus x1. We've already got our y values, and from there we substitute m, which is our perpendicular gradient.